Before we start discussing lines today, I want to mention that I've started putting our lecture notes here on Pearson. You actually have to click the My Lab and Mastering tab to get to it, to the Pearson homepage, and then click on Document Sharing and look for the things that say Class Lecture Notes. You'll only have 4 things here. I have a couple of dozen as I store stuff right there. Like here's like 2020, March 2nd, I have lecture notes. Y'all don't need to see those. Here are the lecture notes from March the 4th, 2020. The ones that y'all will have are these first 4 things: cut points, circles, class lecture notes, Tuesday, Thursday. That's part 1. And then I'll have the class lecture notes for lines and circles. So every few days we'll be putting up all the lecture notes that go along with the videos. That go along, I mean, it's the problems, what I'm writing out when we're making the videos. Okay, any questions about that? My brother will also have those posted on Canvas, hopefully by the end of the day. Okay, so if you want to just look on Canvas rather than document sharing. Today we're going to be discussing functions, and let's see, I don't think it's a I don't think y'all are going to find it too rigorous, but
sir, you don't know how.
Yeah, I know. If I could judge, I've taught the same lesson for 32 years here at Del Mar, so I have a pretty good idea of what to expect. But, you know, you can't judge the future. Well, if you can judge the future by the repeated past, this is not going to be the thing that causes y'all to panic and run out and drop the class. Okay? So,
to repeat itself.
Let's see. So, let's start off. We're looking at functions, and I'm going to define what a function is in algebra. A function is a rule which assigns each x value, we can say either 1 and only 1, or I'm going to say exactly 1 y value. Each x value gets assigned exactly 1 y value, not 2 or 3 y values. Exactly 1. There's a special name for the x values in a function. We'll call the x values the domain, and the y values we'll call range. When we were looking at the cut point method, there were 2 names for the denominator cut points. We could have also called it domain cut points, and I'll justify why that is in a moment. So a function is a rule which assigns each x value exactly 1 y value, not 2 y values, not 3 y values, only 1 y value. Let's look at problem number 1. Determine whether the correspondence is a function. Well, they're using the word correspondence the way I'm using rule. Let me write this problem down. I have a domain and range. The 3 x values are 9, 8, and 3. The y values, the range, 10 and 13. Now let me draw these arrows.
I think that this is a function because it says only 1 y value. It doesn't say each are unique.
Yes, it doesn't say the y values have to be unique. Like the number 9 is assigned one y value, the number 10. The number 8 is assigned
13.
Just one y value, the number 13.
And 3 is assigned to 10.
And 3 is assigned to 10.
And because they each only have one arrow going off of them,
that's it.
It's a
Did you hear what he just said? There's just one arrow going on this. Oh, I'm sorry. There's my domain and range. The number 9 is assigned only one y value. The x value 8 assigned only one y value. The x value 3, just one y value. This thing is a function. It is a function. The natural question to ask would be, what would it have to look like to not be a function? Well, if one of these x values had two arrows, like the number 3 is being assigned the 10, if this had been here, I'm putting a dotted arrow, because it's just imaginary, it's not really part of the problem. But if there'd been two arrows, like right here, 3 would be assigned a y value of 10 and 13. Then that would have not been a function. Y'all see what I mean by those little green dotted arrow? If that green arrow were actually there, then your answer would be not a function. So let me click on, is it a function? Oh, yeah, okay. I'll check it and move on. Determine whether the domain and range of the relation, determine the domain and range of the relation and tell whether the relation is a function. Well, they're using every rule except, they're using every word except rule, aren't they? I said rule in my definition, and they're using correspondence, relation. Let me write this down. 6, 0.
20 negative 7. 44, 0. 6 and 5. And 48 and 5. We can kind of oversee that because there's two sixes. It's not a function.
Okay. But let me first. Okay, so. By the way, the instructions, I said when I defined function, I said rule, but there's nothing special about that word. So far, they've used every word except rule, like correspondence.
Maybe because they heard you
and
say rule and doing it to spite you.
Yeah, relation. So I still prefer the word rule. A function, if you want to say a function is a correspondence, which assigns each x value exactly one y value, that's fine, or even relation, but I prefer rule. And I sort of like this right here. Okay? This problem asks us to state the domain. So I'm going to go G equals, and I'm just going to write down what I'm going to have to type in a moment. 6, 20, 44. Oh, when you're listing out the domain, don't repeat a number. Don't repeat the 6. If you do, I think it'll say wrong and tell you don't repeat the numbers. And 48.
But because of the fact that you had to tell us that don't repeat numbers means that it can't be a function because there's repeating numbers in the domain. Let's
see. Let me just first type in those numbers. 6, comma, 20, comma, 44, comma.
Just to make sure that we can't repeat any numbers.
Let me see. If I put in the 6, let me see. What would happen? it says use a comma to separate your answers. Type each answer only once. It's going to count it wrong because I listed the 6 twice. Okay? Be sure that you've listed each value only once. Okay?
It's just good to check just in case.
There. Now let me check it. Okay. Now it says write out the range. So let me do that. Those are the y values. We're not going to repeat anything. So we have 0, -7,
and 5.
Don't repeat 0, 5.
And we can't repeat the 5 again.
This is one of those problems you can probably do without actually writing down everything. 0,
it's good to just make sure.
comma, -7, comma, 5. And now it's asking, is this a function?
No.
Well, I like these things like this with the arrows. And if we started drawing arrows, like 6 is assigned the y value 0, are there going to be 2 arrows coming out of one of these numbers?
Yes.
Yeah, that's 6, 5. You'll see why the answer on this is no. It is not a function.
If there's more numbers in the domain than the range, then it's not a function. That's not a
If there's more numbers in the domain, no.
That doesn't make sense because
No.
the first one is like that.
So, let me click not a function. Y'all see why I'm saying it's not a function?
Yes.
Let me see. Is it a function? No.
Not a. No.
Now, could y'all figure out a way to look at this set of ordered pairs and decide it's not a function without actually writing the arrows like I'm doing?
Yes, if we just see the fact that there's 2 x values that are the same.
Okay. There's 2 ways to define function in algebra. You can do my rule right here, my first definition, rule which assigns each x value exactly one value. Another way you might see function defined. A function is a set of ordered pairs in which no x values are repeated. A function is a set of ordered pairs in which no x values are repeated.
Can you like click the arrow?
Oh,
or
let me move.
No. I'm pretty sure like if you click the arrow like on the computer, that arrow that's in between the multi-scan and pause, I'm pretty sure that just lowers the toolbar so that.
Let me look at that. I'll be darned. I've never seen that. Oh wow.
Yeah, so it opens
Okay,
up
well,
the screen a bit more.
Yeah. Any questions on that definition? If you have a set of ordered pairs and there's repeated x's, it's not a function. Okay? Let's say this. Repeated x's, arrow, not a function. What if the y's are repeated? Is there a problem with that?
No, because
No.
it could still be a function.
Like right here on this one, number 1. Let's see. 9 was 10 paired to 10, and 3 was paired to 10. Repeated y's, I'm just going to say they're okay. Can't have repeated x's in order for it to be a function, but you sure can have repeated y's.
I feel like this might be possibly the easiest one.
Well, this assignment is not too, it gets a little bit more involved, but here's a question, okay?
Doing something x plus b,
this is just a question. We just finished graphing circles and stuff. Well, maybe you haven't done your homework on it, but that's okay. But we've discussed circles. Even if we hadn't, I think y'all know what a circle is. Are circles functions? Let's just try to think our way through this with the idea of repeated x's. If there's repeated x's, not a function.
I think that, no, they can't.
I think you're thinking correctly. I'm going to draw.
Because it's like on the y thing, it's always going to be whatever it is at the point. Like if the point's at 1, the x is always going to be 1.
I'm going to draw a circle centered at 0, 0 with a radius of 3. It's not a good circle. I don't have a compass up here. But pretend this is a circle. It looks horrible.
It looks like an oval.
Yeah. There. Pretend it's a circle.
It's not a function because when it goes across the y-axis, the x value will always be 0.
Do y'all see right there? Do y'all hear what he's saying? If here and here, the x value is 0 up here and the y value is 3. But what about this point right here?
0, negative.
0, negative 3. Do y'all see that that's a repeated x? So what would y'all say the answer to my question is? Are circles functions?
No.
No. Now there really wasn't anything special about the y-axis. Right here at 1, could y'all imagine drawing a little vertical line? This point and this point right here would both have an x value of 1. So once again, repeated x's, like right here. If I drew a vertical line right here at negative 1, this point would have an x value of negative 1, and this point down here, doesn't it repeat the x value of negative 1? So in general, circles are not functions, and the vertical line test. There's something in algebra called the vertical line test. If a vertical line intersects a graph more than once, so in this case twice, it is not a function. It's not a function. If a vertical line, if you can draw a vertical line and it intersects the graph twice or more than twice, not a function. Before we move on and do another question, let's do another problem. Here's another question. Are slanted lines functions?
Yes. Because it is slanted, it's only going in one direction, so it can't have a similar x value if it's slanted.
Okay. Let's see. Okay, I'm just drawing the x-axis, y-axis, and I'm going to draw a slanted line. Notice the y-axis only intersects it once. If you started drawing vertical lines, you could draw as many vertical lines as you want, and
it will always be unique.
Yeah, it only intersects it once. If it intersects more than once, not a function. But for slanted lines, oh yes. For slanted lines functions, yes. Okay. Now, let me start back doing problems. Number 3. Oh, it's a V-shaped figure, and it asks Is this a function?
Yes.
Okay. Notice, I don't need to draw slanted vertical lines, because can y'all see all the vertical lines intersecting it? None of these vertical lines intersect it more than once. And so, is this graph a function? Yes. It's a function because the vertical lines only intersect it once. What about number 4?
No, it's not.
Oh, it's not really a circle. This is more oval, right?
But because it intercepts the y-axis twice, it can't be.
Yeah, just looking at the y-axis, it intersects it twice. Looking at number 1, it intersects it twice. And -1. So, do y'all agree with this being, what did we say, yes or no?
No.
No. What are we doing? We're using the vertical line test to decide if a graph is a function. Oh wait, I think we've almost done this problem.
Yes,
It asks, decide whether the relation defined by the graph to the right defines a function. Wow, they want to use a lot of words. Is this graph a function?
Yes.
Yeah, it's a slanted line, and all slanted lines have, are functions. Okay? That was the question we asked. Are slanted lines functions? Yes. So we will go back over here and say yes. But this one has an extra step to it, or 2 more parts. It says, what is the domain of the graphed relation?
Do we have to do every single point that they cross?
The domain, those are the x values. If we continue drawing this graph out, imagine the x-axis. If we continue drawing it, it would eventually span, right now it's spanning -10 to +10, right? Those are the x values. Yeah. If we keep drawing it out, would it get to -20 to +20? Yeah. Yes. These arrows here mean that it's going up and to the left and down and to the right. Let me just show you how we're going to write this. I'm going to write it like this. The domain of a slanted line, it doesn't matter which direction it's slanting, is parentheses -infinity, infinity. That's a way of writing all real numbers. If you look at this graph, it's going to keep going left and right. Every slanted line will keep going left and right. So, years ago, I remember at a Pearson conference, they asked us, is there something as teachers y'all would like for us to do? And I said, I want a hot button that's parentheses, -infinity, infinity, close parentheses. And the presenter just sort of looked at me and thought of the idiot and went right on along as if I never said anything.
Well, I mean,
but you'll see what I mean, that now that we've typed it, you're going to be typing this -infinity, infinity a lot. This is a fancy way of writing all real numbers. Okay?
Patterson did allow us to have parentheses, something, comma, something,
Yeah.
parentheses. So it would be easier at least to do it.
Oh, I think I'd rather just, if I'm going to have to type it, I prefer just to do the parentheses rather than, okay, click in the blue box and so forth. There.
But for some people,
And
they might think that's easy.
let me see. Oh, I should have copied and pasted before I actually checked the answer. Now, by saying that the domain is -infinity to infinity, that means this graph is moving to the left and to the right forever. Okay?
Down into
Is it also moving up and down forever?
Yes.
That's the Y values, the range. What am I trying to say poorly the range is going to be?
Would it technically be infinity, negative infinity, since it's going
Oh,
up and then
with interval notation, you always put the smaller number first. With cut points, you always go small, comma, large. Oh, shoot. Is that me?
Yes.
Oh, it happens. I'm sorry. I'm sorry about that.
Your brother's just calling.
No,
You're like,
it's
"No."
not him. Okay, so let me see. I guess I'll try it like that. Negative infinity. See, I'd rather just hit little buttons and have to click in this button or that box. So if someone asks you to say something algebraic that'll make you sound smart, you can say the domain of a slanted line is negative infinity to infinity, and the range of a slanted line is negative infinity to infinity. Okay? Any questions over that? Let's see, maybe we have another one of these to do. Okay, look at, oh wow.
It's not a function.
It says decide if this is a function.
It is not a function.
And let's see, hey, maybe I should, do I need to pop it out or can y'all see the graph good enough? Like right here, the y axis is crossing it twice. In fact, there's a lot of vertical lines that are crossing it twice.
It's like a giant stretched out circle.
Uh-huh. So, is this a function?
Nope.
No.
Zero. Oh, wait, that's interesting. It only did actually, that makes sense. That was only a final check for the yes or no answer.
Yes, you only get one chance with yes or no.
Yeah.
Well, not really. You just get it wrong and then you have to finish the problem and then say similar problem. If you'd gotten it wrong here, it wouldn't let you say similar problem until you finished all the other parts. Now here, let me pop this out, and this is going to hopefully explain or demonstrate what the range and domain are. It says, what is the domain?
The domain, wouldn't it
Let's-
be negative 3, positive infinity, because the final x-axis that it's at is negative 3.
Okay, it starts right here at negative 3 on the x-axis, and then it just keeps going and going to the right. So negative 3 to infinity. You always put parentheses at infinity symbols, but what should I put at the negative 3 when I type it in? Should it be a parentheses or a bracket? Parentheses mean don't include that number. Brackets mean include that number. It would be a bracket. Y'all see why? Because there is a point at negative 3.
So it would be bracket, negative 3, infinity, close parentheses.
Okay, did y'all hear that? Let me type it in. What's the domain?
Bracket,
Bracket,
infinity.
negative 3, comma, infinity, close parentheses. What you're saying is that all of the x values, they start at negative 3, and then they just keep getting bigger and bigger. Okay? There are no negative 4 x values or negative 5. Okay? So let me check this one.
And because we can see where on the y-intercept that it's final, which is positive 1, we can do open bracket 1, infinity, close parentheses.
Open bracket 1, comma. For the y values? These little arrows, they mean it's going to keep going to the right, but I think it's going up. Does it look like it's going to continue going up?
Yes.
And continue going down?
Yes.
So will it eventually hit the floor and hit the ceiling in this building?
It could, yes.
Yeah, eventually it will. If we think of the floor as negative infinity, and the ceiling is positive infinity, it sort of would have been nicer. I guess if you look at it like this, here you can definitely tell it's continuing to go up. Do y'all think it looks like it's going up, up, up?
So it'll be negative infinity, positive infinity?
Negative infinity, comma, positive infinity. So parentheses, parentheses, negative infinity, comma, infinity. We'll type that a lot. I shouldn't have done that. Any questions over that? Do y'all sort of have an idea of what we mean by domain and range? How I'm getting this? Okay. The x values start at -3 and then just get bigger and bigger. The y values, they just keep going up and keep going down. That's why we say negative infinity to infinity for the range. Any questions? Now, so we've seen functions. You can see functions as graphs, like a slanted line we said was a function. We could also have a little table like number 1 or a little diagram like that to represent something that is a function. You can list out ordered pairs, and if there's no repeated x's, then it's a function. Another way we can write functions is with equations. So something called function notation. Function notation. We can write functions as equations containing x and y. This is going to look like f times x, f parentheses x. You don't read it as times. It stands for function of x. That notation can be used in place of the letter y.
Yeah, that's how I was always told that when you see f parentheses x.
Pardon me?
What's that function as what now?
Function notation. We can write functions as equations containing x and y. F parentheses x, which is read function of x, can be used in place of the letter y. And if we look at problem 7, find the indicated output. Oh, I haven't used that word today. For this function. Let me write it down. F of x, or if you want to say function of x,
is 4x squared minus 4x.
4x squared minus 4x.
And we're told that x is equal to 0, so function of 0 is 0.
Okay. When working with this function notation, the number inside the parentheses is the x value. You plug it in to get the corresponding y value. That's what this notation is saying. Plug 0 in for x to get the y value. Remember that the definition of function is a rule which assigns each x value only one y value, or exactly one. So 0, the number in the parentheses, that's the x. Plug that 0 in for x, and what are we going to get? Well, 0 squared is 0 times 4 is 0. 4 times 0, 0.
Function of 0 is 0.
So what's the y value being assigned to this x value here? Well, 0. This might not be a good first example because you might think, oh wait, all he did was recopy the number in the parentheses. No, I didn't.
You replace the x's in the equation with 0.
Yes.
Which ironically makes the answer 0.
0. But there's more to it.
Let's do,
Like right here.
Let's do a similar,
Yeah, this problem has several parts. So find f of -1.
So it'll be 4 plus 4 because -1 times -4 would be +4. So it would.
But right here, you square the -1. Do the squaring. Oops. You do the squaring before you multiply by 4. So you plug a -1 in right here.
So -1 squared is just 1.
1
so
times 4.
So it's 4.
4.
Minus 4 parentheses -1 close parentheses, which will just turn it into plus 4.
4. Okay, -4 times -1.
So it will be 8.
So if we were making a little table, the x value -1 is being assigned what y value? The number 8. Notice there's only one answer here, 8. Let me type that in. Okay, now it says find f of 2. F of 2.
It will still be 8. Yes,
Okay. Let's see. What's f of 2? What do? You plug the 2 in for x.
X.
2 squared is 4.
Because it's 2 times 2. 4 times 4 is 16.
Okay, so the first thing would be 16. Then minus what? If I put a 2 here?
It'll be minus
8.
So, and 16 minus 8 equals 8.
Okay, well, it just so happens you got the same number again. That won't always happen. Okay?
It won't always happen, but it might always happen for this equation.
Yeah.
Or for this question, so I say. Because, unless you want to.
No, it wouldn't. I'm glancing at what I did back in spring 2020. And in spring 2020, the answers was 0. Instead of the 8, it was a 5. Instead of this 8 right here, it was a 2. So it's not programmed to always have the same answer here and here.
Well, I more mean of like the equation, like indicating outpost thing, you know. Like I know it won't always equal to 8, but I'm just.
Oh, but they won't even be the same always. So if you're going to say something about function notation, you would say, okay, whatever number's in the parentheses, plug it in for x.
Well, like for this, it will be.
On number 8, it looks strange because it says k. Usually f is used for function, but there's no reason it can't be a k or.
Just like how x and y don't always have to be
x and y. You're right. In physics, you'd be looking at s and t probably. K of x equals x plus 7.
We're told that x should be replaced with 0, so 0 plus 7 was just equal to 7.
So so there's 5 parts to this problem.
Oh, no.
Okay? So let's see. K of x is x plus 7. Find k of 0. All of y'all can do that. Plug a 0 in. And it's just 7. 7. Then plug a negative 4 in. K of negative 4.
Negative 4 plus positive 7 equals 3. Positive 3 because 7 is greater than 4. Bless you.
So plug a negative 4 in for x. So we have negative 4 plus 7.
Which equals to positive 3.
I agree with positive 3. Actually, I think this would have been a better problem 7. I probably should have reversed 7 and 8, but too late now. What did we say that was? Positive 3?
Yeah.
20 short years. We'll be through with this one. K of negative 16, is that what it says?
So it's negative 16 plus 7, which will equal to negative 9.
I bet most of y'all can probably do what he's doing without me writing it all down. I'm trying to show the thought. I'm plugging the negative 16 in for x. Negative 16 plus 7
Equals negative 9.
negative 9.
Sorry, sir, that I'm just like getting these like very quick.
Oh,
It's
that's-
just that I love math. That's my burden.
Oops. K of 20. Oh, yeah, we'll be through here with this problem soon.
So replace x with 20, so 20 plus 7
Oh.
equals 27.
Okay, maybe I'm beating a dead horse at this point. You plug the 20 in for x. I'm not going to write it down. I'll just say 27. Now see where I'm getting 27? Okay, now this one I'm going to write down.
This one is incorrect.
Okay. It says find K of x plus 5. You write it down. K of x plus 5. The moral of the story so far is whatever's in the parentheses, you plug it in for x.
So would it be x plus 5 plus 7? So it would be x plus 12.
Y'all hear that? You, in place of this x, I'm going to put what's in those parentheses, the x plus 5.
So it would be x plus 7, which equals
But we
2.
still have that plus 7.
So it will be, so K
What am I going to have to type in?
x plus 12.
Do y'all agree with x plus 12? Now see how I'm doing this. X plus 12. Whatever's in the parentheses, you plug it in for x.
I'm not sure why, so I'm just having fun with this.
X plus 12. Any questions?
Now, bring on continued questions.
Let's see. In case we haven't, I like this one where it just says all 3 of the numbers you're supposed to plug in, so I don't have to be going back and forth. Let's see, let me write it down. Number 9.
We're multiplying each by 5.
Wow, they're using that letter K a lot.
So the first one would be negative 65. Because 5 times negative 13 is negative 65.
16. I'm writing it down. It's not a whole lot of work. You know, sometimes when you're doing algebra, like when you're doing cut points and stuff, you got a lot of scribble to get the answer. Here, there's not a whole lot of scribble, is there?
There's a lot of bravo.
Let's see. So I've written down. Oh, wait. Okay. Let me lift this up a little. So for the first one, plug a negative 13 in for x. So we have a black 5 times a negative 13. Is that a negative 65?
Yep.
I'll wait to type these in until I've done all of them. Let's see. What about the other one? Black 5 times 16. See, what would that be? That'd be 10 times 5, 50, plus 6 times 5, 30. Is that going to be 80? Yes. And finally, 5 times 21. I agree, 105. Again, this is one of those problems you could do probably without writing it out like I am. Let's see, negative 65. Is that an 80? And what was that other one? 105? Number 10 is the hardest one we've done so far. It says let f of x equals negative 4x plus 5. Find and simplify f of n. I'm joking about it being the hardest one we've done so far. This is one we can do. We just read the problem, type the answer. The moral of the story, I said, was whatever's in the parentheses, you plug it in for x. Do y'all want to tell me what I'm going to type in right here? Perfect. Replace the x with an m. Negative 4m plus 5. Any questions there? Whatever's inside the parentheses, you plug it in for x. Let's see. Number 11. Now that one I'm going to write down and do. Okay, number 11 says f of x is negative 5x plus 6. It says find and simplify f, now don't panic, of 2n minus 5. Okay, so f of x is negative 5x plus 6. We're trying to find f of 2n minus 5. Well, whatever's inside the parentheses, you plug it in for x. So in place of this black x, I'm going to put all of this red 2n minus 5. I think I should have written bigger like my brother. Negative 5 in place of that black x. Oh, and I messed up the colors. Oh. I'm going to replace this black x with the 2n minus 5. I've reversed the colors incorrectly, but it's too late for me to do anything about it. Marking it out and starting it over wouldn't make it better. So in place of this x, I'll put 2n minus 5. Now there's some simplifying that we need to do here. What would y'all do to simplify this? Could we multiply or distribute the negative 5? So we'd have a negative 10n. Is that going to be a plus 25? And we still have that plus 6 on the end. We're not finished yet. What am I going to type in as the answer? What can I combine here? So we'd have a negative 10n plus, when I combine the 25 and 6, am I going to get a 31? What? Working with the functions, whatever's in the parentheses, you plug it in for x. Let me. So I'm going to type negative 10n plus 31. Negative 10n plus 31. Okay. Problem number 12. This is one you can do without any writing. The number in the parentheses is an x. When you're working with these functions, the answer is the y. What am I trying to say the answer is going to be here? I'll give you a hint. Is the answer going to be negative 6 or 9? The number in the parentheses is 1. And is it an x or a y? No. The number in the parentheses is always x. Let me write it down. Oh. F equals, we have these ordered pairs, 1 comma negative 6, 9 comma 1, and 6 negative 4. And it says find f of 1. Find f of 1. The number in the parentheses is always x. Your answer is y. So what is this telling you to do? It says find the y value when x is 1. Having said that, what number is going to be the answer here? Negative 6. Now this is one of the problems that should have had several parts to it, but it didn't. So let's just pretend it did. Suppose it had asked for this. Find f of 9. What would the answer be? A 1. Okay, if x is 9, y is 1. There's still one more problem that we could get out of this set of ordered pairs. Could y'all tell me the next one I'm about to write? F of 6 equals what? What would the answer be there? Negative 4. Okay? Each x value is assigned exactly one y value. Okay? The number 9 is being assigned the y value of 1. The number 6 is being assigned the y value of negative 4. But it didn't ask all of those. Which one am I going to type in? What's it asking for? Just f of 1. What do I type there? Negative 6. Any questions there? So there's another way that we can write functions. These are as, you can have them as ordered pairs, or let's see, they might be written as little formulas or equations, whatever you want to call them. Up here, just that little function, that little formula there. It's pretty easy to find the domain and range when you're given a set of ordered pairs. They're working on the internet, and now here it's pretty easy to find the domain and the range when you just have a set of ordered pairs. Now, if it's a graph, it takes a little bit more thought. Let's see, now here, for a slanted line, the domain and range is all real numbers. This one, the domain would be negative 3 to infinity. The range, all real numbers, negative infinity to infinity. The natural question to ask is, how do you find the domain? And you might not want to ask this question, okay? But we need to do number 13, and then I'll get to what I'm about to say. I forgot about number 13. This is one that I don't want to write it down because I don't want to have to draw that graph out. Okay? Let me see. It says find f of -2. The number in the parentheses is your x. The answer is the y. That's what we were saying here on number 12. The number in the parentheses, that's the x. Your answer is the y value. On number 13...
So would the first one, because it's -2, would it technically be 0 since you don't go up at all?
You look at this point, y'all see where my mouse is? The y value there is 0. So f of -2 would be 0. I'm just going to write these down. And then I'll punch them all in once I close up the graph. Okay? B says to find f of 10. C is f of 3. And D is f of 4. All I'm doing is writing down the problem, but I don't want to... See. See the answers. Oops. These are the x values. Look at the graph to find the y value. Is it clear what we're going to be doing here? Because you might be thinking to yourself, well, or you might leave and say, well, Mr. Precella didn't help at all. All he did was just look at the problem and say the answer. There's not a lot I can do. Okay? There's not a lot of scribble on this problem. So looking at that number 13, the second part, oh, it's f of 0. I wrote f of 10 right here. This number here should be a 0. Okay. So part B, find f of 0. Can y'all look at the graph and tell me what y'all think f of 0 is? Here's 0 on the x-axis. 4. Now what about f of 3? So locate 3 on the x-axis.
It'll be +2.
Is it up to +2? And the very last one, f of 4 is?
4.
Yeah, the y value is 4 there. Are there any questions how I'm getting these numbers that I'm about to type in? Because the only way I can type them in is to close up the graph. Okay. So 0, 4, oh, no, yes, 4, you had it, I'm exhausted, 0, skin, 2, and another 4. Okay. And let's go to the next one because I started telling them about number 14 before I realized we hadn't done 13. Earlier I said it's easy to find the domain when it's just a set of ordered pairs or if it's a graph. But what's the domain when the function is written as an equation or as a formula? Well, okay. You want to? How to find the domain of, let's see, a function equation, or if you want to call it a formula. I think sometimes in Pearson will refer to it as a formula when it's written as a function, or as an equation rather than just ordered pairs or a graph. Well, one way you already know. We never want a 0 on the bottom of a fraction. So we want to avoid getting a number over 0. And what about square roots? If we're only interested in real numbers, We never want a negative under the square root of a fraction. Because at this point, we're only looking at real numbers, x and y. Why are we only looking at real numbers? When we talk about the x-axis and the y-axis, are there any imaginary numbers on the x-axis and y-axis? Well, no. So, problem number 14, two things you want to avoid. Undefined results, denominators of 0, and square roots of negatives. Now, if you're going to get a denominator of 0, what must appear in the equation? In order to get a denominator of 0, think about those denominator cut points. What did the inequality have to have for you to have a denominator cut point? Should be obvious, a fraction. Let me write it down.
Okay. So here's number 14. Oh, and I'm covering up these.
14 over x plus 7. Do you remember how we found the denominator cut points here? We'd say we can't have a denominator of 0, so x plus 7
Wait, I'm switching.
can't be 0. This is like DCP stuff when we were doing the cut point method. What's the one number x can't be?
-7.
It can't be -7. Now, what you're actually told to do is find the numbers you can plug in for x. The only number that you can't plug in is -7. So we have multiple choice, but they won't all be multiple choice. So here's how you write. In words, you would say the domain is all real numbers except -7. But we don't want to type in words. We want to type in interval notation. The way you do that, with interval notation at a cut point, you either have an open or closed circle. Do y'all remember at denominator cut points? Were those always open or always closed? Open means include it. You want that number. Opening means don't include it. Close means you include it, that you want that number as a solution.
So it should be an open circle.
Always open circles, and it's everything except -7. How would I write everything except -7 in interval notation? I would start with parentheses, I always use parentheses at infinity symbols, comma, -7 with open circles,
Close parentheses.
Not a bracket,
U.
union because you're on the same number line.
Would it also be parentheses -7, comma, infinity?
Yes,
Positive infinity this time.
yes. This notation is just a fancy way of writing all real numbers except -7.
I remember when textbooks started requiring interval notation for domains like this rather than you writing out the expression, all real numbers except -7. And I think this really hides what it's saying.
I do too, but now I understand why they were doing that. They were already getting ready for this stuff here, doing it on the computer. You couldn't be typing in just the words, all real numbers except. That's why all the textbooks, before my math lab existed, started requiring interval notation instead of real words. And I prefer words,
Let's make sure we understand what we just found. Can we plug in 50 million for x? Is 50 million in the domain? Yes. What about -100,000? Is that in the domain?
Yes.
Yes. The only thing that you cannot plug in for x is -7. Okay, good.
Okay, choose the answer.
Oh, yeah.
And you might be thinking, well, heck, it's pretty easy. I can figure these out just with multiple choice. But they won't all be multiple choice. Okay? Okay. Okay, number 15 says find the domain
Great hiding skills, sir.
x squared minus 9x plus 7. Well, there's...
Okay, ready, switch. Remember, there are two things you want to avoid. You want to avoid
a 0 in the bottom of the fraction or a negative under a square root. On number 15, are there any fractions or square roots? There are no fractions in this equation, no square roots. So I'm going to state a general rule about domains. If there are no fractions and no square roots, the domain is just negative infinity to infinity.
unless you're told otherwise.
Well, yeah.
And like in a business calculus class, we'll have functions like this that are representing cost or revenue, and X is representing quantities produced. Well, you can't produce negative 10 items. So unless you're told otherwise, no fractions, no square roots, the domain is always all real numbers. Okay?
So,
Do I sound mad? It sounded like I sounded mad there.
yeah.
Oh,
Okay.
I'm not mad. I don't know why my voice sounds so...
Let's see.
Oh.
Which one is it? Here. There. All real numbers. There's no square roots and no fractions. Like if I said similar question on this one, if I wanted to do another one of those. What, y'all want to guess what the answer is? This is just another number 15. Negative infinity to infinity. If there's no square roots and no fractions. Oh, this one's a good one. Number 16. F of x equals 9 over x plus 2 plus 1 over x plus 3.
So x cannot be -2 or -3.
Right. Do y'all hear that? This black fraction, that black denominator.
wait.
Oops, oh, I wrote it in.
Switched over again.
Oh,
Be interesting.
there. So here's my thought process. That first denominator can't be 0, so x can't be -2. The second denominator can't be 0, so x can't be -3. But how the heck do we write this in interval notation? In words, you would say all real numbers except -2 and -3. It could be anything else. But the way it has to be written in interval notation, is this one that was multiple choice?
Let me see. I think so.
Oh, okay. Well, you might be thinking, I don't need it. It's multiple choice. They won't all be multiple choice. Okay? If you're going to use interval notation, make sure you put the two numbers in numerical order. Which number should go right here? -2 or -3? -3. That's the one closer to the x-axis. Excuse me, negative infinity. Open circle meaning don't include those, but we're talking about everything else. Y'all see why I'm drawing this number line? Could y'all tell me what the interval notation is going to look like? To say all real numbers except -2 and -3, it would be parentheses.
Negative infinity, comma, -3,
Parentheses.
u, -3, comma, -2,
Two,
parentheses, u, -2,
Two.
comma, infinity, parentheses.
That's just a fancy way of writing all numbers except -2 and -3. Okay?
I still like it written out in words.
Oh yeah, I prefer it in words.
I haven't found any My Math Lab courses that do that, though.
Yeah, but if they ever get it to where you could do it in words, that's what problems I'll be assigning. We'll both be assigning. We were from the old school, and I remember a graduate advisor saying years and years ago, math is hard enough for people as it is. Don't use symbols unnecessarily. If you can write out words, my 95-year-old mother might not know much about algebra, but she can read the words, all real numbers except -2 and -3. Okay, she could handle that. But this interval notation, I don't even know if she could even read out what it says. Parentheses, negative infinity, comma, -2, close parentheses, union. And if she did, I know she wouldn't know what the heck it means. Okay. We're looking at this point only at real numbers. For the rest of the semester, we're just looking at real numbers, and we never want a denominator of 0. We never want an imaginary number. We also don't want a denominator of 0. On number 17,
remember there are two things to avoid: denominators of 0 and square roots and negative numbers. So the stuff, whatever you plug in there, we can't decide, let's plug in 10 here. If we tried to plug in 10 there, we would get 8 minus 20. That's a negative number. There are two things to avoid. Denominators of 0, well, we don't have any denominators here, great. And square roots and negatives. So, have you written it down?
Yes. And problem number 17 is going to be a cut point problem. If you just have a plain, you know what, maybe you should have shown 17 and 18 so that they can tell, maybe have a better idea of what I'm going to be saying. On 17, there's no fraction. I'm going to show you how to do it if there's no fraction. On 18, there's a fraction and a square root. I'll show you how to do it then, okay? But for the first one, if we have a square root, we don't want a negative number under the square root symbol. So we're going to write whatever's under the square root must be greater than or equal to 0. It's okay to have a 0 under that square root symbol. If you want to get your calculator and punch in square root of 0, it's going to give you 0. You can't have a 0 in the bottom of a fraction. Now, to solve an inequality like this, you've got to use cut points. Okay, let me make a note. It's been a while since I've used cut points. Maybe you were just doing the cut point method earlier today if you were working some problems. Use cut points. Start off by solving 8 minus 2x equals 0. To solve that for x, I think I'd move the 2x to the right, so it's a positive 2x, and then do what? Divide by 2. That's what we called a solution cut point. That was an SCP, the solution cut point. And with solution cut points, you look at the symbol. There's an equal to on the greater than. So do y'all remember if there's an equal to for solution cut points, open or close circle? Close. So I'll draw a number line.
Oh, and by the way, there's no denominator cut point because there's no denominator. You just need to know when is 8 minus 2x greater than or equal to 0. So there's only one cut point, and it's a solution cut point.
So it'll be a bracket for 4 because it's including 4.
Yes. Now, how do we decide which region to shade? Do y'all remember that? What number do I usually test?
0.
0. Where would 0 be? Between negative and positive, or between two positives?
Between negative and positive.
Okay, so right here I'm testing 0. And when I'm testing, I'm looking at the thing that has the greater than symbol. That's what I'm looking at. Once I write this purple 8 minus 2x is greater than or equal to 0, I'm through looking at the square root. It's just a short little cut point problem, shorter than anything you had as homework over cut points. If I plug 0 in for x, am I getting a true statement or a false statement?
It will be true because 8 is definitely greater than.
I'd have 8 minus 0, 2 times 0, is greater than or equal to 0.
Yes, that is true.
And that's true, so shade.
And that means the other one.
Cross out.
It will be parentheses, negative infinity, comma, or closed bracket.
And is this one that's multiple choice?
No.
Oh, okay, then type it in.
Any questions before I type this in?
So I'm showing you how to find the domain if there's a square root and no fraction. If there's a square root and no fraction, you take what's under the square root symbol and set it greater than or equal to 0. Find the solution cut point, test an interval.
Okay. So we come over here, we're typing in the interval notation, left parenthesis, negative, there's the infinity, comma, 4, and I need a right bracket there.
These problems, 17 and 18, they're the ones that require some thought.
Require the most.
The most thought, yes.
Okay, number 18.
Let me write it down.
While Tony's writing it down, I notice that we have a fraction. When you have a fraction, what do you know about the denominator?
You
What
never
can it
want
not
To
be?
be greater than 0.
Okay, well, it
Yeah,
can't.
he's getting ahead of us. Okay. Just ignore the square root. You can't have what in the bottom?
0.
0.
It would be greater than 4 months, then it can't equal to 0.
But it's a square root. You don't want it to be less than 0, because if you plug in a 5,
Yeah, but I said to
you're
ignore
getting
the
the
square
root of
Okay.
negative 1, and that's imaginary.
I'm trying to, okay. I'm going to try to point out the difference between 17 and 18.
Okay, let me switch over, Tony. Okay. Go for it. Hold on. Let me switch. There.
On problem number 18, when that square root is in the bottom, you're going to take what's under this radical and go greater than 0. Okay?
Because you don't want a denominator of 0.
But if, like on number 17, if there's no fraction, you set it greater than or equal to 0. The only way that's going to be different, or the only way it will change, is in the dot. If there's not a fraction, then you're going to have a closed circle on the cut point, whereas what happens with the solution cut points, I said, if you have a fraction, you say x minus 6 is greater than 0. How would you find the solution cut point? It's easier than anything you did in homework. You would just say equals 0, x, would it be 6? That's my solution cut point. Open or close circle. Open. There's the difference between 17 and 18. I would draw my number line, locate 6, open circle, and then I would test one of the intervals. I always use 0 to test. Where's 0?
To the left of 6 or to the right of 6? To the left of 6.
Okay, so I'm testing 0. And again, this is much easier than any of the cut point problem homework you had. 0 minus 6 is greater than 0. Is that true or false? You'd have 0 minus 6, that's a negative 6. Greater than 0, that's false. So, what are we going to say the domain is?
Parenthesis or bracket.
Would be, is it parentheses at the 6 because of the open circle? Comma, infinity. And is this one multiple choice too?
Yes. Any questions before I punch in the answer?
Yep.
Because we rewrite it. Once we decide that in a way, I guess she is.
Yeah,
It
is sort of a denominator cut point.
Because we're not allowing it to be equal at 6. But what we're doing is we decide, is the step under the radical greater than or equal to 0 or just greater than 0? And once we make that decision, we never look back at the original problem.
I think it's easier in the long run just doing that. Look at what's under the square root, and then it's just this that I'm circling. That's what you're working with, rather than having to worry about.
But if you're thinking to yourself, well, it's a denominator cut point at 6, so it's open. Yeah, I guess you're right, because that's why it's open.
Mm-hmm. I like that thought. This 6 is a denominator cut point, whereas over here, the 4 is a solution cut point, if you want to think of it like that. Maybe in the future, that's what I should say. I like it like that. But what I normally do is I go from here to this purple statement.
Once you decide that purple statement,
and I never look at that messy fraction again. Okay?
Did we answer your question? Oh, okay. Any other question? A, B, C, or D?
What's the difference between A and D? Oh, I see.
D is including the 6. A is not including 6. We want response A. Do not include 6. Okay. Any other questions there?
Yeah. One more, by the way, I forgot to tell y'all, this is a longer assignment. There's 19 problems rather than the usual 15. Let's see. 1 over x squared minus x minus 6. We've already done a couple that had fractions, like number 16. Okay, we have to say the denominator can't be 0. But these denominators here were already factored. By that I mean there were no exponents on the x's. What am I trying to say we're going to have to do on number 19? The denominator can't be 0. What am I going to have to do to solve this? Factor it. So let's see. Numbers that multiply together to give 6. 1 times 6 or 2 times 3. Draw your two sets of parentheses. X and X. Second sign is minus. So 1 plus, 1 minus. Can y'all figure out which pair is going to work? 2 and 3.
Where will the plus go? To get back that minus x, where is the plus going to go? In front of the 2 or in front of the 3? In front of the 2, I agree.
And then minus. Set each one of these to 0.
Not equal to 0.
Well,
same thing.
Yes. And now that it's written like that, I think it's as easy as number 16. X can't be what? Negative 2. Over here on the red one, X can't be positive 3. This is not a multiple choice one, right?
Yes.
So let me do it. Let's see. Let's practice writing this in interval notation.
Not multiple choice.
In words, the domain is all numbers except negative 2 and 3. But See, here, those are definitely denominator cut
I forgot
points.
to put -3.
Oh,
Oh, it is 3.
Oh, it's a positive 3.
You said
The,
-3 and that confused me.
oh, I did? Okay, so all numbers except -2 and +3. I'm sorry about that. So, can y'all picture all the numbers except for -2 and 3?
Wait a minute, Tony. You checked intervals on number 18. Why aren't you checking intervals on number 19? Are we using the cut point method down here? Mm-mm.
Is
There's
this
no
why I don't
square
have to
root there.
check the intervals here? You
There's-
check the intervals when there's square roots. You don't have to do any of the testing the interval when it's just a fraction. Okay, like on 16, there's all numbers except -2 and -3. Here it's all numbers except -2 and +3. So parentheses.
Negative infinity, comma, -2 parentheses, u, -2 positive 3 parentheses, u, positive 3 infinity parentheses.
And it's this one we got to type it in.
Yes.
That's why I've been writing out the little graph trying to show you, because they're not all multiple choice.
So we go left parenthesis, negative infinity, comma, -2, right parenthesis, union, left parenthesis, -2, comma, 3, right parenthesis, union, left parenthesis, 3, comma, infinity, right parenthesis. That's just a fancy way of saying that x, you can plug in any x value you want to, except for -2 and +3.
Now, I'll get it recorded right now. I want to mention that. Oh, okay. At this point, all of the lecture notes, you can find them 2 places. On document sharing and also under files on Canvas.
Yes.
Okay? And I don't think I'll post today's lecture notes. I'm going to get a few days worth before I do the scanning and uploading. It's as much effort to upload 20 pages as it is
There's the
just one
first
day's
part
work.
of the notes, and there's lines and circles.
So you have the lecture notes and the videos going over everything. Okay? If you have any questions, then